Well, good evening, everybody. Welcome to the second HyperLedger Eugene presentation, and I also combine this one with the blockchain meetup, but in future they will be separate. That's because we haven't had any meetups for a while, and I wanted to make sure that everybody had the opportunity to attend one. So, just before we start, a little bit of housekeeping, as they say. Just a bit about me. I've been in technology since 1995. Actually, I started just about the same time as the web, or a little bit after. I was a developer for a few years, and then I transitioned to what now is called DevOps at the end of almost before 2000 in actual fact. Since 2001 I've been fully involved in capacity planning and tuning and designing infrastructures and so on, from dedicated servers through virtual servers through cloud, and on we're going now to the edge, which I'll talk about in tonight's presentation. And in February of this year I actually formed two blockchain groups in Eugene, the Eugene blockchain group and HyperLedger Eugene. And we're going to concentrate this evening on HyperLedger. Towards the end I'm going to introduce possibly introduce a little application that we're looking at for a different project. But anyway, tonight is largely dedicated to HyperLedger, and in particular Fabric. So what I thought I'd do first of all is explain what HyperLedger is and what they contain. So HyperLedger is part of the Linux Foundation. It was really started in terms of contributions of projects by HyperLedger Fabric, which was actually donated from IBM. And IBM, I believe, are a major supporter or sponsor of HyperLedger. But HyperLedger itself is a consortium, is a good word, of different projects, and I'll run through them quickly here. The two main blockchain projects that are up to version 1.0 are Fabric, which I say we're going to talk about tonight, and Sawtooth. They're both different, just as every other project in the HyperLedger consortium is. Just quickly, so Sawtooth, the biggest difference on that particular, in my opinion anyway, is what they use as the consensus algorithm, which is quite garnering quite a lot of interest. It's called Proof of Elapsed Time, or POET, and Sawtooth was contributed by Intel. And it's actually, the consensus algorithm is related to the Intel processor. I won't go deeply into any of these apart from Fabric eventually, but that's what sets Sawtooth apart from other modules, and it particularly gets linked with supply chain type applications, although I'm sure it's more than that. Iroha, that's one that's basically aimed more at mobile blockchain applications. Another thing I should say as well is blockchain. There are other chains that aren't blockchains. We talked about this in the first meetup in actual fact. So I'll keep using the term blockchain because it's more well known. But I will step back at this point and just say what the main differentiators are in this whole world of blockchain. And of course, there's probably, stepping back even further, as probably as many of you know in this room, the first blockchain-based, I don't know that application is the right word, but I'll use that gained any great momentum, and it still has great momentum, was Bitcoin. And it wasn't really until Ethereum came out, which is 2015, where people began to realise that there was this other accessible or usable paradigm called blockchain, and Ethereum really was the first non-cryptocurrency of any scale blockchain, and they also introduced the era of what is called smart contracts, which are basically applications. So in Bitcoin at that time anyway, you couldn't really write applications for it. Ethereum changed that. But the main underlying principle in these things is peer-to-peer. That's the first thing. All of the things that are termed chains or blockchains are peer-to-peer. So they, in theory, don't need a centralized entity to let the applications work and so on. But the reality is we haven't quite got there yet, because even Bitcoin has exchanges which are sort of centralization points. There are, I believe, the inception of decentralized exchanges, but I personally have never been interested so much in in the cryptocurrency, and particularly not the speculation. It doesn't hold any interest for me at all, but that's just me. So the other aspect of and distributed ledger technology actually is a better term than blockchain, so I'm going to use that going forward. Distributed ledger technology. So the other main aspect, or the other main differentiations, is there are two kinds at this point in time: permissioned and permissionless. Permissioned is what basically most of the HyperLedger project is. It's aimed more at business case users at this point in time, and it's permissioned in the sense that in order to take part in one of the distributed ledgers, you have to have permission to do so. And I believe Sawtooth can also run permissionless, but largely speaking, the aim of the HyperLedger is for the permission. So in other words, I'll say that again: permission, you have to be invited to join or approved to join. It's not a permissionless distributed ledger such as Bitcoin and Ethereum and others, where anybody can join. There's no limitation to that. Of course, the other main characteristic of distributed ledger technology is that it's immutable, and just to sort of emphasize that, you can still find the original Bitcoin transaction, which is very famous now, 2 pizzas for 10,000 Bitcoin. It's quite interesting when you think about what the value of Bitcoin is now. Even though it's gone down a little, it's still pretty considerable. So let me carry on now that I step back into cryptocurrencies, blockchains, distributed ledgers, and so on. So Iroha, as I was saying, is a project that's more aimed at mobile distributed ledgers. Fabric we're going to talk about in more detail shortly. HyperLedger Burrow is a main really feature of that is you can run the Ethereum virtual machine in Burrow. HyperLedger Indy, which really interests me greatly because of the last meetup we had was about GDPR in Europe. And HyperLedger Indy is a self-sovereign identity distributed ledger, which really means that the point of this being that we have control of our own data, and it can't just be subsumed like it is nowadays by people like Facebook and Google and so on. So here's the other projects in HyperLedger. I apologise for 2 slides, but I couldn't get this into one slide and make it readable really. So Caliper is a blockchain or a distributed ledger benchmark tool, which will allow us to look at performance. That's a very important part of all this, because as I'm sure we've heard, both certainly Bitcoin and also Ethereum suffer a little bit from performance problems, because as more transactions take place, as the blocks get bigger, then the response times get slower. Then we've got Cello. This is more for people who maybe don't want to have their own distributed ledgers and want something on demand as a service. HyperLedger Composer is basically, I'll call it an IDE, but that's probably a bit of a misnomer. But it's a tool for creating distributed ledger technologies, mainly at the moment Fabric. HyperLedger Explorer allows us to look at our distributed ledgers and see what transactions are on those and how they grouped and so on and so forth, if that is the case. And HyperLedger Quilt, which is the latest really in these modules, was actually donated by Ripple. You may have heard of Ripple as a cryptocurrency, largely speaking for the financial sector. But the other main part about about Quilt is it's based on Java, and it's really the first. Java as a programming language hasn't been that heavily used in distributed ledgers yet, but Quilt and Ripple probably set to change that. And I'll just make a mention about the languages that I've encountered so far in the distributed ledger blockchain world. The two that are sort of new are certainly Solidity, which is the Ethereum virtual machine code, which is very JavaScript-like, and then Golang, or Go, which is a Google language, had already been used in other things, but it's used quite regularly in distributed ledger construction. The other things I've come across are Python. I mentioned JavaScript, Java a little bit now, C++. Those are the main languages I've encountered so far in the work that I've done in the distributed ledger world. So it's not completely new software. There are immense developer opportunities. I can't stress that enough. So with that being said, let's move on. And as I said, we're going to talk about HyperLedger Fabric, and I'll tell you the main reason for that from my point of view as an interest. I'm working on two projects at the moment, which are blockchain based. One's called Earth Dollar, which is a cryptocurrency based on assets, and then the other is called Digisphere Labs, and that's basically the initial initiatives will be to create biofuel facilities which use landfill waste and other forms of waste to eventually create fuel, largely speaking diesel and kerosene, and that's a pretty interesting one for me, and my involvement in that is one of really heading up the information technology aspect of it, and that will involve a lot of what's called industrial Internet of Things, which I'll touch on a little bit more shortly. What that basically means is machines rigged up with sensors, and then with the advent of artificial intelligence or AI, it will become more and more doable to have machines talking to machines and making decisions without human intervention. Obviously that will have to be closely monitored and controlled as to what can be done at that level, but the idea is to make things need less maintenance, be safer, and operate more efficiently. So this is a schematic of what Fabric is constructed like. It's actually a bit different to a lot of other distributed ledger technologies. This will become clearer as I go through. I just wanted to throw up a schematic just to show that it's not just one layer. It's not just peer-to-peer, one device talking to another. There's more to it than that. And here's a schematic for the Internet of Things, and what we're seeing here is, as you can see, some sort of manufacturing facility and power utility and so on. And what we're going to see, which we're already seeing now, and it's been around for a while in actual fact, is devices communicating with devices. Up to now it's been more devices communicating with some other form of intelligence, be it human or some sort of computer. It might be sending data to the cloud. Personally speaking, I don't see that as the long term of the Internet of Things, because what we're going to move to, and I'm going to talk about that, is much more of an edge computing type environment where the external cloud will be used, largely speaking, for analytics and storage of legacy data rather than minute-to-minute operational needs. And the reason for that is the most, I think, vital illustration of that is autonomous vehicles, because autonomous vehicles will be talking to each other, and there's no way there's time to let a request go from one autonomous vehicle to some cloud somewhere, back down from the cloud to another autonomous vehicle if there's about to be an accident. So that's where edge computing is going to come in, and it will come in also in the Internet of Things, because machines running hot, cold, fast, slow, whatever the wrong paradigm is, really needs something to be acted on immediately to restrict damage and restrict danger. So that's again just a schematic here of the Industrial Internet of Things. This is another schematic of actually what I'm going to be involved in, and it's very simple. It's simplified here. But this is a landfill methane outreach program, which is taking landfill waste and other waste and processing it, and bringing from that methane in some cases, and also, like I said, biofuels, those being largely diesel and kerosene, which are fairly polluting fuels and are used quite heavily, in commerce and in passenger aircraft and freight aircraft and so on. So again, this is just a quick schematic. There'll be lots more devices, and what we'll be doing with the sensors is measuring things like what is the input pressure of the gas meant to be at this particular piece of equipment, and what's the output temperature of the gas meant to be, and the pressure and the temperature and so on, and the flow rate. And those sensors will be monitoring those characteristics to make sure that nothing is wrong. And if something is wrong, then it will be actioned or reported upon immediately, so that something can be done to prevent either further damage or, as I say, harm to other pieces of equipment or people, which is obviously very considerable. So this is a little bit more about HyperLedger Fabric. So HyperLedger Fabric leverages container technology to host smart contracts called chain code that comprise the application logic of the system. That's important, as I mentioned before. Ethereum ushered in the era of creating applications to run on distributed ledgers, and Fabric is just building on that. And as it says here, it was initially contributed by Digital Asset and IBM as a result of the first hackathon. Somebody mentioned that on the evening, in actual fact. So we'll move on a little bit here. Here we go back to the schematic of Fabric, HyperLedger Fabric, separating transaction endorsement from consensus. That's the important point. That's the important characteristic of Fabric. And the other thing about the consensus, it uses Byzantine fault-tolerant consensus, which is a fairly well thought of consensus, as opposed to things like proof of work, which is what Bitcoin and Ethereum use, and that's what's causing that to be slow. Those two to be slow, and others that maybe use proof of work too. Byzantine fault tolerance is a more scalable algorithm, consensus algorithm. The good thing though about Fabric, in the way that it's built, is you can see that middle core, the orange systems there. That's the consensus service, and you can plug and play other consensus algorithms, not service is the wrong word, algorithms into Fabric. So you're not left with only the consensus algorithm that was built in there in the first place. So with that, we'll go a little bit further. Oh, one thing I did want to say, almost all the HyperLedger projects, you can go to the HyperLedger Consortium website and download code that you can play with and use, and I'd really strongly advise that. It's free. They have free training out there too. And as I was saying a minute ago, one thing as I'm in the sharp end, you could say, of the IT environment in real-time use of distributed ledgers, it's really difficult to find developers that have got any skill set in distributed ledger technology, and that's not their fault. It's just grown so quickly that the demand far outstrips supply. It was hard enough in technology before to find good developers before blockchain came along, distributed ledger technology. Now it's really, really difficult. And also we have an issue going on with the H-1B visa system in the States. So there's a real demand. sort of emphasising that again, demand is outstripping supply quite seriously. So if I had any advice to any of you, it's get your hands dirty with distributed ledger technology, because it's not going away, and it's very powerful and it's being embraced by so many, but as I say, there's such a lack of developers. That being said, on we go. This is a video that explains HyperLedger Fabric. I can't really jump out of this here because I'm recording this, but I'm going to tag on this video at the end of the presentation somehow so that you can take a look at it. It's a really good little video. It's about 2 minutes 40 seconds long, and it explains Fabric in a way much more succinctly than I can, and with visuals, which is even better. So as I say, I'll tag that on somehow. So here's the other really big thing that's going on, another schematic. This is what's called edge computing, and I'll restate what I said a little while ago. Pretty much all devices, whether they be residential or business, are going to have sensors on them, and they're going to be sending data to be used for different purposes. Those are what I would term edge devices. So you're talking, you could have what could we pick here? I mean, that factory in the middle, which is meant to be a factory, that, depending on what it is, that could have easily 20 or 30,000 edge devices. Each sensor is an edge device, because it's capable of sending its own data. So we're talking of, as it says on the right hand side of this slide, billions of edge devices. It's going to turn computing into a new phase, because like I said to you before, we go to the other end of this diagram, which is cloud data centers. They'll be used, and Mark Andreessen actually did a very good video on this, but the cloud computing end of things is going to be used for, as I said earlier, analytics and storing legacy data. Most of certainly in the facilities we're going to design for biofuels, they'll have their own data centers in essence. I use that as an analogy, because we're going to need very timely responses as and when needed at the edge. And these edge devices will run through gateways. I was looking at one today. We're looking very closely at Siemens and a product called Mindshare, and they use gateways. And these things are going to be really quite revolutionary, because they're not anything tremendously different. It's Arduino typically, with Linux running on there, and by adding SD cards you can do a lot of stuff on the actual gateways. So that, to me, they're going to be, we could think of them as being mini servers with capabilities to do things that relate to this sensor data that's coming in. So that would be what it shows up here, sort of as fog nodes, fog as opposed to cloud. So and I can see technologies it's going. Obviously, the gateways will get more and more powerful and capable, and so the cloud, I feel, and I mentioned this Mark Andreessen video, I feel that the days of cloud computing are in its heyday as it has been, are gonna morph into something much more like the second and third layer going down on this triangle. So that's edge computing. Again, if you're looking at things to invest in knowledge-wise for the future, I would certainly look at into edge computing. So that's the end of the Fabric presentation that we're doing. RetroShare is a little application. It's not a HyperLedger application. I don't know whether it ever will be, but it's basically a peer-to-peer messaging system, which we're testing out for another project I'm working on here in Eugene, Oregon. It's called HyperLedger, which relates to sustainable farming and permaculture, and we're going to use RetroShare as a communication mechanism between people who are in the HyperLedger, so that we're not at the behest of centralized services. I think the next slide just shows what's contained in there, and then I'm going to stop. I'm not going to go any deeper into RetroShare because really I wanted to keep focused on HyperLedger itself and Fabric this evening. So let me just move on to the one of these slides has, yeah, so this is a slide I wanted to show because what's in RetroShare, I do recommend you taking a look at it because it's certainly going to, if it spreads, it's going to weaken the grip of things like, you know, Google and Facebook and Twitter. So it's got chat, it's got voice and video, it's got email basically, file sharing, forums, you can share favourite links, you can have different channels to you know, to sort of group things into, and you can use Tor too with TOR with it, you know, to get an even greater level of security. So that being said, that's the presentation as it is. Typically I take questions at the end, but we can't really record that, but hopefully this is, for those who get to see it, is useful and an insight into what we actually presented at the last HyperLedger Eugene or Eugene HyperLedger meetup. Thank you.